Okay, great. So now that we did part 1, we're going to move on to part 2. So part 1, we looked at the initial value, which was the y-intercept. So whenever I see the word initial value or starting or anything with those words, I know that that means y-intercept. So now I'm going to look at question number 2. And I'm going to ask myself that same question. So based on the key words in this question, what key feature am I trying to identify? Based on the keywords in this question, what key feature am I trying to identify? So for part B, let me do the same thing. And I'm just going to write evaluation steps. So for part A, I found the y-intercept. For part B, I'm going to identify my key feature again. So I want to know what key feature I'm using. Based on the keywords. Key feature. And if I look at this, the keywords here is how long is the ball in the air? Well, I see the word how long is the ball in the air. And I know that how long can mean like how long something is, so like its length. And I also know that if someone asks me how long is something happening, that's the time. So when I'm looking at this problem, it makes more sense that the word how long is the ball in the air means that I'm looking for the time. So I'm looking for T. And it says, is the ball in the air? So how long is the ball in the air? So when I think about that, I already know the initial height is 9 feet. So it's starting at 9 feet, and I want to know how long it's in the air. So then I know that I'm going to stop my time when the ball hits the ground. So that means if I want to know how long the ball is in the air, I'm looking for the time after it hits the ground. So the time when it hits the ground. So based on what I know about this, I'm going to draw a little sketch. So I'm going to draw a sketch. Because I'm still trying to identify this key feature here. So I'm looking for the time it takes when it hits the ground. So if I'm going to think about what that means, I know that this ball is going to start at 9 feet. And I know that it's going to go up into the air. And then eventually it's going to come back down and hit the ground. So this is when it's on the ground. And when I see this point where it's on the ground, I can see that this is my x-intercept. So now I'm looking for how long the ball was in the air, or essentially when it hits the ground. I'm looking for the x-intercept. Because when it's on the ground, the height is going to be 0. So now I'm going to use that, what I know, that the height is equal to 0. And I'm going to substitute that into my equation. So I can solve for t. So now I'm looking for the x-intercept or the root. So I know that in order to find this value, I can use a bunch of different methods. So because this is my evaluation step for a root or an x-intercept. So I have my sketch. Now I'm going to actually substitute. So I substitute 0 for the height. And now I'm going to solve for t. So I'm going to use the structure of this equation to solve for t. So I can factor or use the quadratic formula. When I think about this structure of this equation, what makes the most sense to me would be to see if this is factorable. So in order to determine if this is factorable, I need to determine, are there two numbers that multiply to negative 16 times 9 and add to 45? So when I think about that, I want to multiply negative 16 times 9, and I get negative 144. So can I think of two numbers that multiply to negative 144 and add to 45? Well, let's see. When I think about factors of 144, I think of 12 and 12, or negative 12 and 12. I think of negative 4 and 36. I think of 72 and 2, 48 and 3. So based on what I know about this, I know that if I do negative or positive 48 and negative 3, if I add those together, I'm going to get negative 45, and if I multiply them, I get negative 144. So now I'm going to do what I know, which is factor by grouping, and I'm going to replace this b value with my factors. So I'm going to get 0 equals negative 16t squared. Or I shouldn't write there, it's not going to fit. 0 equals negative 16t squared plus 48t minus 3t plus 9. Now I'm going to group the first two and the second two. Between negative 16 and 48, I know the GCF is going to be a negative. T, and that leaves me with t minus 3, and then negative 3 and 9 is going to be negative 3, and then this is t minus 3. And as always, I need to rewrite these. So I take the GCFs, negative 16t and negative 3, and I write negative 16t minus 3, and then I take my t minus 3 and t minus 3 since they're the same, and I write t minus 3, and now I set each one equal to 0. So I get t minus 3 equals 0, and negative 16t minus 3 equals 0. So here I get t equals 3 over negative 16, and here I get t equals 3. So I get two answers for my time. So the ball is either in the air for negative 3 over 16 seconds or 3 seconds. And when I think about the first answer, which is negative 3 over 16 seconds, I have to ask myself, does that make sense? Can something be in the air, or can something be happening for negative 3/16 of a second? And no, it can't. That makes no sense. Not because it's 3/16 of a second, because that can happen, but because it's negative. And I know that it's physically impossible for time to be negative or have a negative value, because we can't go backwards in time. We can't move to the left when we're talking about time. So that means the answer has to be 3. So the answer to my question, or my final answer, so I have to write this out as a final answer, is going to be the ball was in the air for 3 seconds. And I'm just going to write that here. The ball was in the air for 3 seconds. Great. So I know this part B was a little bit more confusing than part A. Part B will more likely be on an IA or an SAT or any type of test than part A, since part A is a lot easier. But please make sure that you write all this down and come to class ready to ask and answer and practice some projectile motion questions. Thanks, guys, and have a great day.